All right, so by learning the if statement, we've covered the positive case. We can unlock extra functionality when we set up and encounter a true condition. But how do we also add responsive content in the negative case? We do so using else. The if-else statement provides an alternative path of execution. If the Boolean expression is true, the if block executes. If it's false, the else block executes. The two blocks are mutually exclusive. One or the other will run, but never both. So if we go to our code and we have our example about the test or the final score of a grade, we have this current condition. We evaluate whether score is above 59.9, in which case the person passes the class. But if score is not above that threshold and the condition is false, then we can write an else block. And then if that Boolean expression is false, this is the block that will run, the else. So we could say you did not pass the class. So if we run that, we see down here, you did not pass the class. Now our program is dynamic because it executes differently based on different input. So let's return to our Boombox example. We have this Boombox class, and it's already responsive to if a user types that they like music. So if we just say yes, Boombox will say, great, I like music too. But if we say no, it doesn't print anything because there's no negative condition. Nothing will execute if the answer is false, if the answer returns as false. So we throw in an else statement there, and then we are free to make responsive logic in response to a false. So Boombox might say, oh, that's too bad. So if we run this program, do you like music? If we say no, Boombox will say, oh, that's too bad. However, it is just looking for an affirmative yes in order to execute the true block. So we could say anything that's not yes. We could even say yeah. And it returns as false because what was entered is not exactly yes. And we can go further than this even, because now we have the ability to handle two conditions, true or false, using if and else. But Java offers ways of having multiple paths, more than just two. And one of the ways that it offers this is through the else if statement. The if else if statement combination is perfect for testing a series of mutually exclusive conditions. The program evaluates each condition in order and executes the block for the first one that is true. Once a condition is met, the rest of the statement is skipped. So a good example for this is the following. So again, if we have a numeric score that we call, or that we assign to the number 76, and then we want to assign that to a letter grade. So we make a char variable and we'll call it grade. So we can start off simply and say if score is less than 60, then the letter grade is F. And then based on what we know so far, the only thing that we're familiar with would be that the grade is not an F in this else statement here. So if we want to test for different conditions, we say else if, and then we add a new parentheses to give us a Boolean expression, and we write another Boolean expression. And in this case, what we'd like to do is test if score is less than 70. And then we open up a code block for this condition. And so we know that if a score is less than 60 in terms of grades, that's considered an F. And now we're saying, okay, well, if the score is actually greater than 60 but less than 70, we're now handling that condition. And because we know about this domain, we know what grade that would be, we can write that logic here. So we know that if a grade is lower than 70 but greater than 60, that it's some kind of a D. And then this follows for the rest of the grades. So we want to say if score is less than 80, then we'll assign grade to the character C, and else if score is less than 90, then we'll assign grade to B. Right, so what we're doing is these conditions are mutually exclusive. So, and it will continue from the first one, which is the first is score less than 60, and it will continue to go down until it finds a condition that matches. So is the score less than 60? Is it less than 70? Is it less than 80? Is it less than 90? And if all of those are false, it goes on to the last condition, which is like a catch-all. I haven't found anything that fits yet. So this is the last one, and it will never get here if it finds a true condition anytime before it. And this is the final else. And in this case, if we haven't found any true statements before this, we know that grade has to be A. Because going by the logic of all these choices, it has to be greater than 90, and it can't be greater than 100. So we'll assume that. So in this case, the else condition is going to be an A. And then, of course, after all that, we are free to work with the grade variable. Your grade is grade, and print it out. So in this case, it'll print out a C because it's greater than 70 and less than 80. That must be a C. And then we can always change this around as we see fit. All right, so let's try to do an example using our boombox functionality. So returning to that, I will copy and paste kind of what we had before with this boombox app, but take a look at this. We have one change so far, which is to add in a Boolean variable called likes music, and we initially started off as false, and then we prompt the user to say first, do you like music? And if they type yes, then we print our message that we had before. but we also set this Boolean flag to true. If not, we still print that's too bad, but that's it for the program. However, now we have access to that Boolean flag, so we can evaluate based on that. So if the user likes music, now we can do additional functionality that is unlocked, essentially. And so let's say that we are using this Boombox program as a music recommendation engine. So if you like music, Boombox could say to you, I can recommend you an artist. What's your favorite genre? And then from here, we can just come up with our own set of if-else statements to check for if a user typed in a genre of music that we can provide a recommendation for. So for example, starting off, if the user likes rap music, then Boombox can recommend Rio de Young OG. Else, if the user says that they like rock music, we can recommend them the Philadelphia indie rock band Algernon Cadwallader. If the user said they like electronic music or country or soul, we can additionally add in recommendations based on that type of music. However, if the user typed in something else, none of those, so the user did not type rap, rock, electronic, country, or soul, maybe they typed something else, at this point we can just have our program say no recommendations yet. So that's a pretty good catch-all because the program doesn't know what that means yet. But so far, pretty decent. Let's give it a quick run and see if it's gonna work. So hi, I'm Boombox. Do you like music? Yes. I can recommend you an artist. What's your favorite genre? I'll say soul, and it'll say listen to D'Angelo. If I rerun the program, I'll say yes, I like music, and I'll say I like rock, and it will tell me to listen to Algernon Cadwallader. Alright, so this was just a different type of example that shows both Boolean flags as well as using if-else statements with strings, which again have a different type of comparison that you need to use rather than numbers or characters directly. Strings use the equals method because they're not primitive data types. The final concept to familiarize ourselves with in terms of program paths is the switch statement. The switch statement provides another way to create multi-branch decision structures. It's ideal when you need to check a single variable or expression against a series of discrete values, called the case. Switch statements in Java have gone through a lot of changes through the years. I'll try to introduce the most important parts of its evolution so you can understand how we got to switch in its modern form. The core part of the switch statement is the case. The case is the equals part, or right side, of a Boolean expression. With switch statements, we define cases, and if the left side of the Boolean expression matches a case, then we do whatever the case block says. So let's look at our Boombox code, just a section of it, and we'll convert those if-else statements into the switch statements. So the first thing we'll do, we'll bring back some of the logic for Boombox. We'll take out some of it. We'll just keep things simple. We just want to know the user's favorite genre. And then we will make a variable that will be a string that will hold the recommendation. So type of music is the user's favorite type of music, and if that matches a switch statement's case, then we'll store that result as a recommendation. So let's check out what the switch statement would look like. So here's an example of a semi-modern type of switch statement. I don't think we need to worry about the old switch statements, but you can take a look at them in chapter 3 of the textbook. Additionally, you can search it up on Google to understand the older style of switch statements in Java. But what you see on the screen is a semi-modern way to do switch statements. What's going on here is type of music becomes a case, or yes. Type of music becomes the expression to be evaluated. So we await response from a user to indicate their favorite genre of music. And then when we receive that type of music, we then evaluate what they entered, what they typed in, against a series of cases, just like we did with our else-if statements. But in the way of writing switch statements, we call each choice a case. So in this case, all we say, it's more simplified, it's less lines of code than a bunch of else-if statements. So basically we're saying, evaluate whatever type of music is. This is the user typed in their favorite type of music. And if it happened to be the word rap, then we're going to assign the variable recommendation to this string. Listen to Rio de Young OG. If it was rock, if they typed in rock, assign it to this, and so forth. Again, if the switch statement doesn't find any cases that match, then it's not going to assign anything, and we use the word default. We use the default case to say, in this case, no recommendations yet. And as we've implemented this, now at the end, we have set our variable recommendation to one of these choices, even if it's the default choice, in which case it found no match. The default case in a switch statement is like the final else statement in an else-if else series of statements. So if we run this, it runs basically the same way as it did before. We say our favorite genre, and it makes a recommendation. We say we like country, and it makes a recommendation. And then finally, if we say something that's not listed, like jazz, it says no recommendations yet, just like with our else-if statements. So the switch statement in Java works very similarly to a series of else-if statements, and sometimes it is preferred because it cuts down on repetitive logic and numbers of lines written. Now, there is a principle in Java that's actually called don't repeat yourself. So anytime in Java you find yourself repeating yourself or writing something more than once, many times over, you're repeating yourself, and you should think of ways that you might be able to avoid repeating yourself. Now, I see some repetition in our example already. I see a lot of repetition, actually. I see the word listen to numerous times. So that indicates to me that that's a candidate for removal. So now, if I'm using the word listen to in every one of my string outputs, my recommendations, why don't I just add it before the actual recommendation? And then I could go through and remove that from my options. But there's still a lot of repetition. We see this line, recommendation equals, in every single case. So now this is modern Java. What modern Java allows us to do is, instead of initializing this recommendation string as null, as just empty, what we can do is we can actually say string recommendation equals switch. And that is followed up with a semicolon at the end there. And then, because we're already assigning the result of a case match to the variable recommendation, we don't need to worry about assigning recommendation to any string. Java just takes care of that for us. So now we have a very efficient way of handling multiple potential paths. This works the exact same way as what we saw previously. So if we run this, we say we love soul music, and it does that recommendation for us. Now, of course, you can also add in more cases as you like. If you say you like funk music, you probably want to recommend Funkadelic. So now we've added another case in there. All right, yeah. So that is switch statements, and I will say, I'll just close by just also mentioning that switch statements also work for non-strings or for primitive data types, of course. So the way that would look is what we had earlier when I was explaining. I just want to mention that so now if you look at this, after I've explained kind of what these things mean, basically your switch case here, the condition on which to evaluate which branch we're going to take. So if you have a program that asks somebody what their birthday is, and you tell them to type a number for which month they're born in, and they type the number 2, you could use a switch statement to associate the number 2, the case 2, which is month, with the string February. So if we run this, we see February. But what this actually means is it's saying this element right here is just saying, what does this evaluate to? So if I just wrote the number 2 here, it would automatically assign it to this value 2. So what's in the parentheses there is what's being evaluated. And if it finds a match in the cases, in 1, 2, 3, or default, or it will take that path. So I think that this is just a good way to think about it in terms of numeric switch statements. You can think of it evaluates what is in the parentheses. It doesn't evaluate for true false like our if statements do, but it just evaluates whatever the condition is. And then if it finds a match within the cases, then it will follow that. So I hope that's clear. And yeah.